Welcome to Ask and Learn.
So in this question, we have this liquid sensor. It is able to tell us what is the level of the liquid in this cylindrical container based on the capacitance of this capacitor. So first, let's write down the equation, the capacitance for the equation for the cylindrical capacitor. So we have C equals 2 pi epsilon naught. And then when, of course, when the dielectric constant, we add it here, times its length divided by over R, A over RB. This is the capacitance of a cylindrical capacitor. So here, because we have, we can think of this capacitor as two capacitors connected in parallel. One is liquid and one is vapor. So we can think of it as C equivalent equals the liquid one plus the vapor one. And okay, so just, I know some people might start to think that this looks like two capacitors in series, but the thing is, if we have a parallel plate capacitance that has two dielectric materials like Kv and K liquid, this will be in series, because what happens is that you can see the bottom of the top material and the top of the bottom material are at the same pressure, at the same potential. But this is not the same for cylindrical cases, because in the cylindrical case, say the middle is a positive and the outside is a negative. So when they're connected like this, it's like connecting their positive plates together and connecting their negative plates together. That's why we think of them as two capacitors connected in parallel instead of series. But anyway, that will give us in 2 pi epsilon naught over ln Ra divided by Rb. That is the same. But then we have K liquid times the height of liquid plus K vapor times L minus H. So, and this equals C. I'll call it cylinder. So C is the final capacitance. And we want to write this in terms of, H over L, because we want to find the fraction of the tank that is filled. So that is H over L. So let's try to produce H over L over here. If we time L here, and we divide L here, this becomes 1 divided by H over L. Good. Now we can rearrange it. Let's see. This parenthesis is equal to Kv plus K liquid minus Kv times H over L. So H over L equals C times ln Ra over Rb over 2 pi epsilon naught L. This. So now we have this on the left side, and we subtract Kv, and then divided by 1 over K liquid minus K vapor. So that would be the fraction in terms of the capacitance. And then in part B, we're given the actual numbers, and then we ask what values of capacitors correspond to the tank being completely full and completely empty. So now we have to go back to this expression. When it's completely full, that is when H equals L. What we have is C equals 2 pi epsilon naught L divided by ln RA over RB times, because H equals L, the vapor part is going to disappear. So it's just K liquid times H over L is 1. So that is it. So that is 2 pi times 8.85 times 10 to the negative 12 times 2.0 meter times 1.0 over ln of 5 millimeter over 4.5 millimeter equals 1.5 times 10 to the negative 9 farad. And same when it's empty, we do not have any liquid parts. So when it's empty, H equals 0. So we have the whole container, but with the dielectric coefficient of vapor. And we do the same calculation, except that instead of, sorry, this is 1.4. Instead of 1.4, we use 1.0 times 1.0. And we get 1.1 times 10 to the negative 9 farad.